Today we're going to look at perpendicular lines. Yesterday we looked at parallel lines and also lines with special slopes. So for the warm-up, let's review. Draw and label the following on the coordinate grid to the right. So the first line is y equals 4, which tells us that the y-intercept is 4 and the slope is 0. So that's going to be a horizontal line at y equals 4. So here's the starting value. The slope is 0. So here's that first line, and again we'll label it line A or y equals 4. The second line is y equals negative 2, so that's telling us the y-intercept is negative 2. Again, the slope is 0. So there's our line, y equals negative 2. X equals negative 1. That means where x is negative 1, it doesn't matter what the y is. All along this line, x equals negative 1. So that's going to be a vertical line at x equals negative 1. And the last one will be, let's use a different color here. It's green. X equals 3. So what that means is it doesn't matter what the y value is. X equals 3 right here. And we'll label it x equals 3. So if it's an x equals line, it's vertical. If it's a y equals line, it's horizontal. Okay, notes for today. Write the equation of each line in slope-intercept form. All right, so for each of these, we need the y-intercept, so the first one's 1, and the slope, if you pick any 2 points, is rise over run. So this first line, line A, is y equals 2/3 x plus 1. Line B, the y-intercept is negative 4, and the slope is 2/3. Y equals 2/3 x minus 4. These two lines are called parallel lines because their slopes are the same. So they're never going to intersect. Same slope, different y-intercepts. How about these lines right here? So let's look at line C. Let's come up with the equation of the line. So line C, the y-intercept is 3. The slope is 1 over 2 or 1/2. So we have y equals 1/2 x plus 3. And let's look at line D right here. The y-intercept is negative 2, and the slope is negative 2 over 1. Okay, let's do a few more of these, and we're going to find, let me turn the volume down on this. Okay, so let's do a few more of these, and then we'll look for a pattern. So this line right here, E, has a y-intercept of negative 1, and the slope is negative 1, 2, 3 over 2. So we have y equals negative 3 over 2x, and the y-intercept was negative 1. Let's take a look at E. Oh, that was E. Okay, let's take a look at F. All right, so F, if we look at the y-intercept, it's about, we'll estimate negative 5.5. And then if we pick any 2 points and find that slope, it is positive 2 over 3. So we have y equals 2 over 3x minus 5.5. And let's look at one more before we start finding patterns here. G and H. So let's look at G first. Okay, so the y-intercept, again, let's estimate negative 5.5. But then if we pick any 2 points, this is positive 2 over 3. Is that the same? Huh, it's the same. Okay, I guess I didn't change that. Okay. So let's just look at the first two then, since these are the same. The question, what angle do these sets of lines meet at? Okay, so if you look, all of these lines, if we were to measure using a protractor, they meet at a 90-degree angle. So this line meets at a 90-degree angle too. Okay, so they meet at a 90-degree angle. And what kinds of lines are these? They're called perpendicular lines. Okay, so let's fill the definition and take a look at the pattern that we noticed. So they're called perpendicular. lines. They meet at right angles. If one has a positive slope is going up, the other must have a negative slope. And it's going down, and these are called opposite reciprocals. So let's go back to these right here. Okay, so this first example, if one is going up, the other has to go down so they can meet at a right angle. And if you look at their slopes, this will tell you if they're perpendicular. If one is flipped and the opposite, so one was 1/2, so the other is flipped 2/1, and it's the opposite, so one's positive and one's negative. And if that's true, the lines are perpendicular. Let's go to this example. Again, notice they meet at a 90-degree angle. And if you look at the slopes, one is negative, one is positive, and they're flipped. That means the lines are perpendicular. So perpendicular, they meet at right angles. If one has a positive slope is going up, the other is negative. And they're called opposite reciprocals. That's when you flip it and change the sign. So for example, given one slope, write the slope of the perpendicular line. So if one slope is -7/8, the other one would be positive because this is negative, and you would flip it. 8/7 would be the perpendicular slope. If one slope is 3, that's the same as 3/1. The perpendicular slope would be the opposite, so negative, and you would flip it, -1/3. 8/7 is a perpendicular slope, -1/3. The next one, 1/4, you would flip it, be negative 4/1, or you could just write it as -4. Both of those would work. -4 is perpendicular to 1/4. And the last one, -7, is the same as -7/1. So if you flip it and change the sign, the perpendicular slope is 1/7. Last type of example, are these parallel, perpendicular, or neither? Determine whether these two lines, KM and ST, are parallel, perpendicular, or neither. All right, so if you remember slope formula, slope is y2 minus y1 over x2 minus x1. And there's two lines here, so I'm going to draw a line. KM is the first one. Let's label our points. x1, y1, x2, y2. And the slope is y2 minus y1, so 6 minus a -8, over x2 minus x1, so 1 minus a -1. When you have a minus a negative, you'll turn it into a positive, and so here our slope is 14/2, and reduce that if possible. We can divide 14 divided by 2 is the same as 7/1, or 7. All right, so there's the first slope. Now, if it's parallel, it will have the same slope. If it's perpendicular, it'll be flipped to negative. Otherwise, it's neither. So yes, let's use slope formula for the second line. Label it x1, y1, x2, y2. Our slope is y2 minus y1 over x2 minus x1, so 2 minus a -2. Again, when you have minus a negative, that turns into a positive. And we have 16/4, and that reduces to 4/1. So take a look at these. They're not the same. They're not parallel. They're not flipped to negative. They're not perpendicular. So these are neither right here. All right, let's try the next two and see what we can find. Again, here's slope formula. y2 minus y1 over x2 minus x1. Okay, so let's divide up our lines. Let's label our points x1, y1, x2, y2. So slope is 4 minus a -2 over 5 minus a -5. If there's a double negative here, minus a negative turns into a positive, so we have 6/10. Let's reduce that. That's 3/5. We can divide each of those by 2 because they're even. 6 divided by 2 is 3, 10 divided by 2 is 5. So there's our slope, 3/5. All right, let's look at the next slope, x1, y1, x2, y2. Slope is y2 minus y1 over x2 minus x1. We get -10 over minus a negative turns into a positive, -10/6. They're both even numbers, so we can divide each of those by 2. -10 divided by 2 is -5. 6 divided by 2 is 3. Oh, look, they're flipped and they're negative. So this means that the two lines are perpendicular. And then the last one, I can't move it down anymore, so I'm just going to take a screenshot of it. Again, let's split this up. Label our line, our points, x1, y1, x2, y2. And slope is y2 minus y1 over x2 minus x1, which is 6 over negative 2, which if we reduce is negative 3, or negative 3 over 1. Let's label our next one x1, y1, x2, y2. Slope is 3 minus 0 over 4 minus 5, which is 3 over negative 1. Okay, our slopes are the same, so these two lines would be parallel if we were to graph them. All right, so you're going to practice this idea of finding parallel perpendicular slopes. Remember, parallel is the same and perpendicular is the opposite reciprocal. It's flipped in the opposite.